Okay, AP Calculus AB. I'm going to use our ti-nspire CX CAS to find the area bounded by two trigonometric functions. And this is not normally the way I would find area bounded, but if you look at two trig functions, they might be cyclical. So let's take a look at this for a second, see if you can tell what I'm talking about here. So here are these two functions. And if you can see, the area I'm looking for is the area between the red curve and the blue curve from here to here, or from here to here. And those areas reoccur over and over and over again. The problem is that if you try to set this up on your calculator to figure out one area of intersection, like the one I want is this one right here. But if I was trying to figure that out, well then it would get kind of difficult. So this is what I'm going to do instead. What I'm going to do instead, if you set these things equal to each other, if you said to your calculator, solve sine of x is equal to cosine of x, it's going to give you back kind of an algorithm that's going to tell you all of the intersections, but none of them specifically. It's going to be in terms of an n value, of an integer value. So what I'm going to do instead is this. What I'm going to do is this. I'm going to take a look at this, and I'm going to look from where they intersect right here and right here. And so I wrote this little note at the top that says sine of x is over cosine of x on our interval. So I'm saying from here to here, sine of x is over cosine of x. So all I'm going to do is I'm going to set this up, knowing what we know about integrals. I'm going to set this up, and I'm going to input a new function here. And I'm going to say this. I'm going to say this. I'm going to say, give me sine of x minus cosine of x. Whoops, sorry about that. Go back, cosine of x. I'm going to put minus here, all right? Then I'm going to graph that, and something really cool happens. And if you can see, I don't know how well you can see. Let me move some of this crap out of the way. Let me move this out of the way. Let me move this out of the way. If you can see where these two, the blue curve and the red curve intersect, here and here, is the same place that this curve intersects the x-axis. So now that I've done that, all I have to do is this. I'm just going to go to Menu. I'm going to go to Analyze Graph. I'm going to go to Integral. And then it's going to ask me which graph. Remember to choose the black graph, so I chose graph 3. Chose this graph. Well, hello. I'm going to go to Menu again, Analyze Graph, Integral. I'm going to choose the black graph now. What I'm going to do here is this. I'm going to go here and see if, as I draw my cursor across it, where it intersects the x-axis, it says line of intersection. And if I pull that across to here, another intersection point, and there's my answer. So what answer did you just get? You got the answer for what's the area between this red curve and this blue curve on all these intervals. It is 2.83. In other cases, I would do this a different way, but in this case it's a really good way. When you're having a hard time figuring out where two curves intersect, just graph them and use this method. So I hope this is really helpful. Your comments are always welcome. If you haven't already subscribed, please subscribe. Thanks, appreciate it. Oh, also, can you try to keep in mind that you have a couple minutes for every question on the AP exam multiple choice, so slow down a little bit. You're going to be fine, okay? Good work.